All right, 1.5 practice. We'll be continuing graphing systems of equations to solve. But starting with some warm-up problems here, we are looking to combine a -8 and a -3. The signs are the same. So that means we are going to add them, 8, 9, 10, 11, and then keep the sign. On number 2, we have a +2 and a -5. Our signs are different, so we'll subtract. 5 minus 2 makes 3, and we keep the sign of the larger number, which is negative. In number 3, we're multiplying. When we multiply, if our signs are different, our answer is negative. So we do 2 times 2 to get 4. Our signs are different, so we get -4. And in number 4, when we're dividing, our signs are the same, so our answer is going to be positive, and 5 divided by 1 is 5. For each equation, in number 5, 2 is multiplying with v. The opposite or inverse of multiplication is division, so we are going to divide 2 to both sides to find that v is equal to 4 divided by 2, which is 2. In number 6, we are doing the inverse to both sides. I'm getting x by itself, which means I need to move this -11. We do the inverse operation. The opposite of subtracting 11 is to add 11. I'm looking at my signs, a -25 and a +11. Our signs are different, which means we'll subtract to get 14, and then keep the sign of the larger number, which was negative. Number 7 is a 2-step equation, which means we have 2 steps in order to get x by itself. In the first step, we need to subtract 8. Those cancel out, so that x divided by 4 is equal to, follow our sign rules, different signs, +6, -8, subtract, and keep the sign of the larger number. So x divided by 4 is equal to -2. Next, we have to get rid of a 4 that is dividing, and we get rid of dividing with multiplying. And x will equal -8. In number 8, we have distribution. So we are going to distribute first. 5 times 3 is 15, and 5 times r is 5r. Once we've distributed, then we can begin to solve our equation. We will subtract 15 to both sides first, and be left with 5r is equal to 30 minus 15, which is 15. Five is multiplying with r, and we get rid of multiplication by applying division. Division undoes multiplication. So when we divide those, 1r is equal to 15 divided by 5, which is 3. All right, in number 9, we are graphing. I'm going to write my m equals and b equals for number 9. So my m equals -2 over 5, which means we're going down to right 5, and my b equals -1. So we are going to begin at -1, and then we move down to right 5. We're also allowed to do the exact opposite. We could go up and left. So I could go up 2, 1, 2, and left 1, 2, 3, 4, 5. That line is just awful. It's hard to line these up on the tablet. We put arrows on our line because it does extend. And that's that line. So for number 10, m equals 1 over 1, because it's 1x. It's positive, so it's going up. And we always go right. b equals 1. So for this one, we're going to begin at positive 1 and move up 1, right 1, up 1, right 1, up 1, right 1, so on and so forth. Okay. Numbers 11 and 12, I'm going to write my m equals b equals. Numbers 13 and 14, I am going to color coordinate them and write my arrows, but I'm not going to write any other information. So let's see, I'm going to use red for my first equation. And m equals negative 2 over 1, which means we're going down and right. b equals negative 1. Now I could do everything for my red equation first if I want to. I can begin at negative 1 and then count down to right 1, down to right 1. I can also do the exact opposite and go up to left 1, up to left 1, up to left 1, and put my line. So I could do my entire graphing work and then go and just graph my second equation. Or I can do, I can write all the information down. I could have done this and then just graphed. So this is going to be a positive 2, which I made look like a z. Let's see. Positive 2 over 1. It's positive, so it's going up. And then b equals 3. So we're going to begin at 3 and then move up to right 1. And we can also apply the exact opposite and go down to left 1. And red and blue, where they cross to make purple, is our solution. So our solution to this system of equations is our x value, so negative 1, that's our x value, comma our y value, which is positive 1. All right, number 12, I'm going to color coordinate again. So I have my red equation. M equals 7 over 1, that's up 7, right 1. B equals negative 3. If I were to plot that, I would find negative 3 and then count up 7. 1, 2, 3, 4, 5, 6, 7, right 1. So there's my 7 over 1. There's not going to be enough room on this graph to do that to have more than 2 points. Okay, and then in blue, for my blue equation, our m is 1 over 1 and our b is 3. So we are going to begin at 3 and then count up 1, right 1. And that gives us that line there. We find where our points overlap, where they intersect, and then we describe it by saying the x coordinate, so the x coordinate of that point, and then the y coordinate. And we do that in parentheses. So we're going to say x, which is 1, y, which is 4. 1 comma 4 is the solution to that system of equations. Okay. I'm going to do numbers 13 and 14 without writing extra information down. I know that I do have a negative 1, so I'm going down 1, right 1. So I'm going to begin at 2. I got that from here. I'm just not writing it down. Begin at 2, and then I'm counting down 1, right 1. Down 1, right 1. And I can do that all the way across. Could also do it going the other direction. And there's my red line. For my other equation, 1 over 2, I'm going up 1, right 2, and I'm beginning at -4. So I'm going to put a point at -4, and I'm counting up 1, right 2. Up 1, right 2. Connect my points. And then I'm looking for where do they overlap, where do I have red and blue. And then I'm describing it by saying my x value, which is 4. So I'm going to say 4, comma, my y value, which is -2. So 4, comma, -2 is the solution to that system. All right, and then finally, I wanted to show you something like number 14. We haven't really seen this happen before, but this does happen sometimes. So in my first one, I'm moving down 1, right 2. So I'm going to begin at -3 and move down 1, right 2. Down 1, right 2. Can also go up 1, left 2, up 1, left 2. I'll make my line. Okay. And then for my second equation, I'm going down and right, and I'm beginning at 4. So if I begin at 4 and count down 1, right 2, down 1, right 2, or if I go up 1, left 2, you'll notice, hopefully you've noticed, that there's no purple point here. The lines do not cross. And it's not that the graph isn't big enough, it's that because these lines have the same slope, they're always going to be going down 1, right 2, down 1, right 2, down 1, right 2, and this one as well, down 1, right 2, down 1, right 2, down 1, right 2. And because they're going down and right at the same time, because they have the same slope, they're never going to cross. So this equation this solution to this system of equations we would describe as no solution. There's no point where these lines will cross for infinity. So there's just no solution to these because our slope is the same. And the slope has to be exactly the same.